Okay guys, so today is lesson P6. My hope is that we can get through the lesson here. Hopeful. I'm going to push for it. And then on the assignment, and I'll write at the bottom of the assignment when we get there, but I do want to point out that everything is evens. Okay, so it's 2 through 16, that's evens. 26 and 28. 34 through 38, which pretty much is 34, 36, 38, 42, and 44. But everything is evens on that, just so you are aware. Okay, so lesson P6 goes back and reviews complex numbers, which we first learned last year in Algebra 2. Okay, what do you remember? Well, first of all, let me ask, you know what I mean when I say complex numbers? Okay, numbers with I. When we officially talk about complex numbers, we are looking at numbers of the form A plus BI. If you recall, A is the real... Okay, I think my recording... Oh, no, my recording is just way behind. Didn't know it could do that. That was weird. Okay, so I represents the imaginary unit. It is the square root of -1. So anytime you have a negative under your square root, that is represented by I. The other important one that we use a lot is I squared. What is I squared? -1. Because when you square a square root, you get whatever's under the bracket. Yes? Okay. So, some basics here. Example 1, we get to review adding and subtracting. Don't make this harder than what it is. The adding and subtracting part is the easy part, right? If we're adding 7 minus 3i plus 4 plus 5i. Notice what kind of sign is in between the parentheses there? That is a plus. So, add them up. What do we get? Ross? He says 11 plus 2i? It's like terms, right? 7 plus 4 is 11. This is a -3i plus 5i, so plus 2i. Can I go any farther? No, they're not like terms past that. Okay, so even though I is not a variable, we treat it like a variable in this sense. Okay, B, 2 minus I minus 8 plus 3i. Thoughts on what 2 minus I minus 8 plus 3i cleans up to be? Jace? -6 minus 4i. Put like pieces together, remember subtract. We have 2 minus 8, that's the easy part, right? 2 minus 8 is -6. And then the next part is -I minus 3i. The key is remember to subtract everything in that second parenthesis, yes? So -I minus 3i is that minus 4i, because it's like -1 minus 3. Okay, so far so good? Okay, multiplying complex numbers. How do we multiply two binomials? FOIL, right? Okay, your hint's right there. It's FOIL. So let's review our FOIL first. 2 times 5 is 10. Outsides. 2 times minus I. Minus or -2i. Insides. 3i times 5. Plus 15i. And last, 3i times minus I. -3i squared. Okay? Continuing along here. What are your thoughts at this point? We could go for?
So since it's I squared, it'd be the same thing as -3 times -1. So then we make that 3.
Okay, so we got two different things to talk about. One of them Remember this idea of negative 3i squared? I should never ever see an I squared in a final answer, because I squared is equal to negative 1. So this now becomes negative 3 times negative 1, which is a positive 3. That's my little side note there. You may not need the side note, but that's my reminder. So this becomes a plus 3 there, doesn't it? We still have a 10 out front. We'll talk about those then in the next step. What can I do there in the middle? Can we go ahead and put those like terms together there? Or you can wait till next step, I guess, if you prefer. But what is negative 2i plus 15i? That's a positive 13i. So we've got our i's together. Now that my minus 3i squared became a positive 3, put that with the 10, and we have 13 plus 13i. They're not like terms, so you are done right there. Okay. The basics coming back to you about how to deal with these i's. Okay. I'll be honest, we don't use i's on a really regular basis. They randomly will pop into things. Kind of like in Algebra 2. We learned them. They would randomly pop up on occasion, but not really. You know, we kind of just kept moving on. And same thing. They randomly pop up in pre-calc, calc. It's more of a, okay, let's remember, how does this all work? Okay. Raising a complex number to a power. So, a complex number, such as z here, where z is defined as 1/2 plus radical 3 over 2 times I. Asking us to find z squared and z cubed. So let's start with the easier part here. How am I going to find z squared? Okay, so we're going to square this, right? What is z? Okay, so yeah, z is this binomial. What happens when you square a binomial? Just like earlier when we did binomial times binomial, we're going to have to FOIL. So you could write z squared as 1/2 plus radical 3 over 2i quantity squared, or realizing that we're going to have to FOIL that. So I'm going to write it out as 1/2 plus radical 3 over 2i times 1/2 plus radical 3 over 2i. Because to do z squared, that means we're doing z times z. Because they're binomials, we can't just square the first term, square the last term. We need to FOIL. Yes, we are foiling with fractions. Yes, you will survive, I promise. First, 1/2 times 1/2. I heard it out there somewhere. 1/4, because 1 times 1 over 2 times 2, 1/4. Okay? Outside. So now I'm doing 1/2 times radical 3 over 2i. So think about the fraction. 1 times radical 3 is radical 3. Denominator. 2 times 2 is 4. And then you have an I. So this next term is going to be radical 3 over 4 times I. Now we do insides. What do you notice about insides? Same thing, isn't it? Radical 3 times 1 on top is radical 3. 2 times 2 in the denominator is 4. And then times an I. And last. Radical 3 over 2i times radical 3 over 2i. Okay. What is radical 3 over radical 3 times radical 3? 3. Can we go just and say 3? Because square root of 3 times square root of 3, if you want to think officially, is square root of 9. But what do you know about the square root of 9? Turns around to be 3. So I'm all for, when you see square root of 3 times square root of 3, let's just say that it is 3. 2 times 2 in my denominator, 4. I times I. I squared. Okay. We've got some cleanup to do. For right now, I'm going to leave 1/4 because 1/4 is the only constant I have for the moment. Radical 3 over 4i plus radical 3 over 4i. Let me make you think about it this way. 1/4 radical 3i plus 1/4 radical 3i. In other words, the radical 3 are like radicals, yes. The i's are like i's, or kind of like variables. So what are the pieces we're really adding? 1/4 plus 1/4, which is 2/4, or 1/2. For this momentary step, I'm going to write it as 2/4. So I'm going to write 2 radical 3 over 4 times I. Realizing I still have to go one more step here, don't I? So I'll simplify from the 2/4 to the 1/2. Now, what do you know about plus 3/4 I squared? I squared is -1, so instead of plus 3/4 I squared, I'm going to just say minus 3/4. Are we okay there? Because now I'm just down to final cleanup. Like terms, one last time. 1/4 minus 3/4. Okay. My brain said -2/4 to begin with, but we know your teacher is going to prefer that you go one step farther than -2/4 and say -1/2 plus, it was 2/4 radical 3i. Well, what did we know about 2/4? It's going to be 1/2. So 1 radical 3 over 2 times I. Your answers to these problems, whether you're adding, subtracting, multiplying, dividing, your answers are going to come out complex numbers, where they are in the form real, plus or minus, an imaginary part. Okay? No I squareds left. Yes?
So was it a coincidence that the only thing we changed was like when we just use that shortcut every time?
Question is it a coincidence that only thing that really changed from the beginning to the end is positive 1/2 became -1/2? I do not know that that is a guaranteed shortcut. I can't say, I cannot 100% say no, that absolutely will not work. But on the other side, I can't say that, you could go for a guess like that. I just can't guarantee that it's going to get you there. And that's where I'm trying to think. I don't know. You'd have to try some examples and see if that always works or if that was just coincidence. Because I don't have an answer for you right there. It does have me curious. Now, that was finding z squared. What else do we still have to find? Z cubed. Well, the back of this page is blank. We only have front page notes today, so if you are totally out of room because you didn't save room because you forgot there's another part to this problem, draw on your own, flip to the back of the page. Now, we can make z cubed really long and difficult, or we could be smart about this. How can we be smart about doing z cubed? Yes, z cubed could be broken down into z squared times z. That saves us having to multiply z times z and then multiply that by z. We can just jump straight into, I just found z squared. Let's use that, right? So z cubed is going to become z squared, which what is z squared? Okay, negative 1/2 plus radical 3 over 2i, and then times z. What is z? Positive 1/2 plus radical 3 over 2i. Okay, so we're there. First, negative 1/2 times positive 1/2. Negative 1/4. This is really awkward timing, but virtual people, I just had a thought, and I don't know if you've all figured it out or not, but like as I look at my virtual screen right now, my screen is really small because it's down in that one corner, because all four of you, there's 3 of you plus me on here. There is a way, if you, and maybe you guys have already done this, where you can pin my screen so that my screen is the main screen that shows and you don't have to see everybody else. Okay, so I don't know if any of you virtual people need that or figure it out, but I forget exactly how to do it. I think it's something if you go up into people, yeah, and you can pin a screen there. So just kind of a heads up in case that's helpful to anybody, because I just figured that part out yesterday. Otherwise, my screen gets really small. So kind of like Zoom, you can pin them. Okay. I know, awkward timing, but I'm realizing if they can't see this, it's really bad.
That happens to me all the time.
Yeah. Okay, so I should have told you guys to finish this while I was talking to them. Did you finish? No. You guys are waiting on me, aren't you? Okay, first was negative 1/2 times positive 1/2, which is negative 1/4. Outsides. Negative 1/2 times positive radical 3 over 2i. So negative times positive makes it negative. 1 times radical 3 is radical 3. 2 times 2 is 4. And then we have our I. Insides. It's positive times positive. Radical 3 over 2i times 1/2. So plus radical 3 times 1. Radical 3. 2 times 2 is 4. Over I. And last, radical 3 over 2i times radical 3 over 2i. What is radical 3 times radical 3 again? 3. 2 times 2 is 4. I times I squared. What's the good news?
They cancel.
These end up being conjugates. My middle term's canceled. Minus radical 3 over 4i plus radical 3 over 4i will cancel. That just made the life a little easier here, didn't it? So then we have negative 1/4 still plus 3/4 I squared. What's plus 3/4 I squared? Minus 3/4, because remember I squared is negative 1, right? So this becomes minus 3/4. What is negative 1/4 minus 3/4? Negative 1. Negative 4/4 if your brain went there first, but it's negative 1. So z cubed is negative 1. Or, how can I express, wasn't going there, but how can I express z cubed in the complex number form? Being that complex number is a plus bi. This is just a regular everyday number. So how can I express it in the a plus bi, so real plus imaginary part, when I only have a real part? Negative 1 plus 0i. Okay, so that's an alternative answer there. It's a good answer to C because honestly, the answer key is likely to have that alternative answer. Because watch your directions in homework. If it says to express your answer as a complex number, they're looking for a real plus imaginary part. Okay, so watch out for that. Ready for the next section then? Okay. We have added and subtracted. We have multiplied. We've raised to powers. Now it's time to, quote, divide. Not going to be a whole lot of dividing here, but. So 2 divided by 3 minus I. The hint is in the directions here, but remember, I is technically a radical, yes? And are we allowed radicals in our denominators? No. And so that is the key there that's going to help. If this is 3 minus some square root, how do you rationalize the denominator? Multiply by the conjugate. So if this is 3 minus I, what's the conjugate of 3 minus I? 3 plus I. Now, if I multiply the denominator by 3 plus I, guess what? You multiply the numerator by 3 plus I. So, how do I multiply on top? How do you multiply 2 times 3 plus I? Distribute the 2. So 2 times 3 is 6, plus 2 times 2i is, 2 times I is 2i. How do I multiply my denominators? Binomial times binomial. We're foiling again. Now, I'm going to FOIL it all out, but if you remember what happens when you FOIL conjugates, the middle terms are designed to cancel, right? That's the whole point of conjugates. But I'm going to multiply it out all the way. Just bear with me. First, 3 times 3, 9. Outsides, 3 times I, plus 3i. Insides, minus I times 3, minus 3i. Last, minus I times I, minus I squared. Okay. So, numerator of 6 plus 2i, I'm just going to leave it as 6 plus 2i for the moment. Denominator, 3i minus 3i, cancels. I have 9. What do you know about minus I squared? Yeah, you could think of it if you want as minus negative 1. Because if it's minus I squared, it's minus negative 1, which is really plus 1. And 9 plus 1 is 10. Okay? 6 plus 2i over 10 is where I'm at. What do I do here? Okay. All 3 terms can divide by 2. So let's reduce everybody by 2, and we now have 3 plus I over 5. Now, it doesn't say it right here, but again, I kind of gave you the warning that if homework asks you to write this in complex number form, so A plus BI form, this is not A plus BI form because this is one fraction. So to make this A plus BI form, we need to split it up, right? We need a real part plus an imaginary part. What's my real part? 3 over 5. plus, what's my imaginary part? You can write it as I over 5, or you can write it as 1/5 I. I'm fine both ways. I'm not sure what the book would do, honestly. Not saying the last answer was incorrect. However, complex form says real plus imaginary part. And I know you heard me tell you that in Algebra 2 also. If you remember it, can't guarantee that, but I'm hoping it's coming back to you. Okay, B. 5 plus I over 2 minus 3I. Thoughts? Okay. Conjugate of the denominator. So 2 plus 3I. If I multiply the denominator by 2 plus 3I, multiplying the numerator by 2 plus 3I. Difference this time is that we are now doing what in the numerator? Foiling instead of distributing. Although technically FOIL is just multiple distributives, but okay. FOIL with me. First, 5 times 2, 10. Outsides, 5 times 3I, 15I. Insides, I times 2, 2I. Last, I times 3I, plus 3I squared. Denominator, outsides, not outsides, what am I doing? First, 4, now outsides. 2 times 3I is 6I. Insides, negative 6I. And last, minus 9I squared. Okay. We got more efficient at this. Can we do more cleanup at once? Let's talk about the numerator. What can happen in the numerator? Okay, so in the numerator, 15I and 2I is going to be 17I. What's this 3I squared going to become? It's really going to turn into minus 3, isn't it? Because I squared becomes negative 1. So 10 minus 3 is 7. Plus, we already decided we had a 17I. So 7 plus 17I. Okay, what about the denominator now? Okay, now we can talk about the fact that our middle terms cancel. And it's going to be 4. What do you know about minus 9I squared? That becomes plus 9. So 4 plus 9 is 13. Reducing? Nope, no reducing. How should I express my final answer here? 7/13 plus 17/13 I, or 17I over 13. The I, just like a variable x, can be written beside the fraction or with the numerator. The only thing you want to be careful of is don't let it look like it's just with the denominator, because that means something totally different. Okay? Okay. Ready for the next one? X squared plus x plus 1 equals 0. Our solving method? Quadratic formulas, what the directions say. And here's the deal, guys, it does not factor. So, I think quadratic formula is kind of where you have to go. If we're talking quadratic formula, start by making sure your equation is equal to 0. Is my equation equal to 0? Yes. Just because, what's A? The 1 in front of the x squared, right? What's B? 1 in front of the x. What's C? The constant 1. Okay, well, Don't worry about mixing ABCs here. Here we go. Negative b. Negative 1 plus or minus the square root b squared. So 1 squared minus 4 times a, which is 1, times c, which is 1, all over 2a, which is 2 times 1. Clean up. Negative 1 plus or minus. What is that radical? Okay, we have 1 squared, which is 1, minus 4 times 1 times 1, which is 4. So 1 minus 4 becomes negative 3. All over 2. Why does this one fit in this lesson so well? Yeah, that negative square root of 3 takes us into the imaginary world. So, do you remember how to do this? X equals negative 1 plus or minus. How do we rewrite that radical negative 3? Okay, the negative comes out as an I, doesn't it? I'll do a little side note over here in case anyone needs it. Right on the screen, yes. Square root of negative 3. Think of it, under that, as negative 1 times 3. And what is the square root of negative 1? I. The square root of 3? I don't know it, so it stays square root of 3. And so, generally speaking, we write that as I square root of 3. You can put the I after the radical, but it's the same thing like putting an X after the radical. You have to be careful to make sure that it doesn't fall under the radical, because that has a whole different meaning there. Okay, so safer bet is to put the I in front of the radical. So, negative 1 plus or minus I radical 3 all over 2. For the purpose of today, and expressing your answer in complex form, what are we going to do here? Negative 1/2 plus or minus, we can write this a couple different ways, I radical 3 over 2 is how I chose to do it. So that denominator 2 goes with both pieces. I left my I in front of the radical, and thus on top. The other option is to put the I off to the right of the fraction, just like you could have variable. Okay? Okay. The one part of this that might be new, I don't know that we ever graphed complex numbers last year. Maybe we did, I just don't remember it, but I don't think that was, you don't remember it? Okay, I don't think we did. Now, here's the deal though. Normally we have an x-axis and a y-axis. The difference now is we have a real axis and an imaginary axis. Okay, so the horizontal axis here is your real axis. Or if you're thinking in the form a plus bi, it's your a. The vertical axis is my imaginary axis. Or kind of, if you want, a b-axis. Notice up there when we're plotting complex numbers. Complex plane, just like the coordinate plane, a plus bi is the ordered pair a, comma, b. So, if we're asked to plot the ordered pair u, u is 1 plus 3i is how they define u. What is 1 plus 3i as an ordered pair? If it's real, comma, imaginary, what's the real part? 1. What's the imaginary part? 3. So to plot the point u, it's 1, comma, 3. How do we do 1, comma, 3? Over 1 up 3? That's all it is, right? Okay, what about the ordered pair for b? If b is the complex number 2 minus I, 2 comma negative 1. And that's because all of these are a comma b, right? So 2 comma negative 1 is going to be going right 2, down 1. And it's always good to make your u and b different somehow. Just beware, u's and b's can morph into the same shape. It's fine, yes, I don't put the, b gets kind of curvy and I don't put the little curl on the u very well. Okay, last one. It wants me to graph u plus v. I'll graph u plus v, I need a word pair. Do I have a word pair for u plus v? I can get one, yes. Take u and v and combine them. U was going to be, I'm going to do it this way, you can do it either way. 1 plus 3i plus v was going to be 2 minus I. Sorry, I got sloppy there. Okay, so when you add u and v, you add like terms. 1 plus 2 makes this 3. 3i minus I makes this 2i. So if it's 3 plus 2i, what is that, the word pair? 3, 2. So write 3, up 2, and that is my u plus v. Okay. Homework. As always, should be in Skyward. But it's also here, page 52. 2 through 16, I'm going to write it like this, evens. And then it's 26, 28, 34, 36, 38, 42, and 44. I wrote it differently than what it says over there, but it's the same numbers. Okay. Did we get everything? I think we got everything. Maybe Monday we can do quizzes.